Hello everybody, today we're doing LeetCode 15 threesome. Given an integer array nums, return all the triplets in an array format, num sub I, num sub j, num sub k, such that I is not equal to j, I is not equal to k, and j is not equal to k. And num sub I plus num sub j plus num sub k equals to 0. Notice that the solution set must not contain duplicates. In example 1, we have an unsorted array input, and we have two possibilities for triplets that does not have any sort of duplicates in the output. So in this example, we have -1, -1, and 2. All of this equals to 0. And we have -1, 0, and 1. This also equals to 0. When it says it doesn't want any triplets, we can see that this -1 plus 1 plus 0 is equal to 0, as well as this -1 plus 1 plus 0 equals to 0. And because they're exactly the same numbers, we don't want that to be in our output. So they'll be distinct triplets. Here is our nums array, and it's unsorted. One way we can go about this is by going by the naive approach. And the naive approach means that there are 3 nested for loops. So we have a pointer for I, one for j, and one for k. And we iterate through it looking for all of the possibilities that any of these triplets will equal to 0. And when it is, we will push them onto a results array. Using 3 nested for loops is pretty timely. That would take our time complexity to n cubed. A way to make this run a little bit more efficiently, we would involve going to using the 2sum2 solution. If you haven't done 2sum2 yet, I highly recommend doing 2sum2 before trying to attempt 2sum3, because that solution will help you tremendously in terms of finding a way to solve threesome. For 2sum2, you're working with a sorted array. And one way we can sort this by just doing a dot sort method on this. So after we've implemented dot sort, this becomes our sorted array from least to greatest. The way that we want to implement 2sum2 to this is that we will have one pointer here, which is I, and we'll have our left pointer here and our right pointer here. Every time we're at I, we'll find left and right every single possibility that will equal up to a triplet. Here we have our sum variable. We also have our results array. And essentially, we want to find where a plus b plus c is equal to 0. And in this case, a is at -4, L is at -1, and R is at 2. So we find the sum for this. This is -5 plus 2 equals to -3. And we take our sum -3 and we compare it to 0. We see that -3 is less than 0. And because -3 is less than 0, that means that the value for L is way too small for it to be possibly in our triplets array. So we're going to move L up by 1. And here's the tricky part. We see that -1 is exactly the same as the number prior, and we don't want to deal with any triplets. So we'll move L along until we find a different number than the one prior. So now L is at 0. -4 plus 0 plus 2 equals to -2, and it's still less than 0. That means L is way too small, and we're going to have to move L up by 1. Now that L is at 1, we have -4 plus 1 plus 2, which equals to -1. We see that -1 is less than 0. We're going to move L up to here. But now L and R are at the same place, which means that we exit out of that loop, because that'll be our condition while left is less than right. So we break out of that while loop. I goes up by 1, and L will automatically be right here. But the problem is that we see that L is the same as the one prior. So we don't want to start L at -1. We actually want to start it at the next place. So we'll move L up to here. So here we have I is -1, L is 0, and R is 2. -1 plus 0 plus 2 equals to 1. We see that I is greater than 0, which means that this value is way too large. So we will decrease r by 1. So now that r is 1, that means we have, so now we have -1 plus 0 plus 1. 0 is equal to 0, and we want to store these values for I, L, and R into our array, -1, 0, and 1. So after that, we'll move I up by 1, but we see that -1 is the same as the one prior, and we don't want to deal with duplicates. We will move I up by another 1 so that I will be at 0. It'll keep iterating through, establishing the left and right pointers, and it will find all the possible triplets and push it onto the result array. So let's talk about time and space complexity. For time, we sort the array, and that is n log n. And we also have a nested for loop, one for I and the other is a while loop. So that takes it to n squared. So asymptotically, n log n times n squared will reduce down to n squared as our time complexity. And for our space, it will be either O of 1 or O of n, because the sorting will take up space depending on the library or language that you use to write this code. So let's see what this will look like in the code. The first thing that we want to do is create our result array, because that's what we're returning. Results is an empty array, return result. The next thing that we want to do is we want to sort our input, sort, comma b in ascending order. So that's a minus b. And we have a sum value that we'll use to find the possible triplets that equal to 0. And we're going to iterate through using I for let I equals 0, I is less than length, I plus. Inside the for loop, we'll initialize our left and right pointers, because that will be our 2-sum-2 solution, where we're looking for A, which is equal to I, B, which is equal to left, and C, which is equal to right. Those 3 pointers will point to the values for A, B, and C. And we want the sum to equal to 0 to finally put it into our result array. Let's let left equals I plus 1, let right equals nums.length minus 1, and we want to have an if condition in here so that if I is the same as the number before, like in our example, if I is right here and it's the same as the number before, we want to go ahead and skip it, and we want to start at I here to look at the next possibility of a triplet that equals to 0. So if nums sub I equals to the one before it, I minus 1, we'll continue. And then here is our while loop, where we're looking for left and right values. So while the pointer's left is less than right, we will update sum at every iteration and compare it to 0 and see where to move the left and right pointers. So let's have sum equals nums sub I plus nums sub left plus nums sub right. And if sum equals to 0, what do? We push this into our array. Nums sub I, nums sub left, and nums sub right. After we push it through, we also want to increase our pointer. And after that, we'll do an else if our sum is less than 0. That means the left's number, b, is way too small, and we want to increase that pointer by 1. Else we'll decrement right by 1. And the last thing that we want to make sure that we do is deal with duplicates. So it's actually in here, when you find a triplet and you've increased left by 1, we're going to have another while loop in here. And it's going to check while nums sub left is equal to nums sub left minus 1. If that is true, we'll increase our left pointer by 1. Let's run the sample test cases. We have a runtime error, result.push nums sub I. Let's run that one more time. Passes our sample test cases. And there you have it. That's a way to go about it. If you liked this video, please help out by liking and subscribing. Thanks for watching.